Good day, students. Welcome to the Accuplacer College Level Mathematics Part 2 sample questions. All right, let's go ahead and take a look at question number 11. So we are asked to find what this expression is equivalent to. So we're dealing with 5y times 2y minus 3 plus 2y minus 3. Okay, so this is assessing our ability to distribute, apply the distributive property, and also how to factorize, okay? How to factor. So let's distribute first. This 5 gets 5y gets distributed to these two terms in the parentheses. So that yields 10y squared. 5y times 3 is negative 15y plus 2y minus 3, okay? All right, let's combine like terms. 10y squared stands alone. It has nothing to be combined with. These two are like terms, so we can combine them. Minus 15 plus 2 is negative 13y minus 3. Okay? Now you notice that all these options are already factored. So let's go ahead and factor this. We're going to apply the factorization technique for trinomials here. So I'm going to use a method called the x game. So fill out the x, and we have AC on the top and B on the bottom. Okay? This is A, B, C, as long as your polynomial is written in standard form, okay, descending order. All right, I also have a tutorial on how to master the art of factoring trinomials. You can go to my site, mathgotserved.com, and view it so that you can really master this algorithm, all right? Okay, so AC is 10 times negative 3, which is negative 30, and B is negative 13. So the question is, what two numbers multiply to give you negative 30 and add to give you negative 13? All right. So to exhaust the possible combinations, I'm going to make a chart of products, all the products that yield, all the pairs that yield 30 when you multiply them together. So I'm going to put 30 up here. So 1 times 30 is 30. These two combinations yielded a 29 or 31. I need 13, so that's no good. 2 times 15. If I combine these two, I can get 17 or 13. Wow, that works. So let's try it. So 2 and 15. Since the sum is negative, that means the bigger number has to be negative. Okay, let me just tell you something real quick. Let's try some more combinations just to highlight a point. So 3 and 10. Check this out. 3 and 10 can give you 13. But the thing is, if you put them here, there is no way you can combine 3 and 10 in such a way that their sum is negative 13 and their product is negative 30. So actually, this combination right here is a trap. Okay? So you have to be really careful with the signs. The signs must pan out because sometimes you might have more than one combination that works, but when you look at the signs, you'll be able to identify which one is an accurate one and which one is a trap. Okay? So you got to be really careful with that. All right. So the correct pair that we need to use for this problem is 2 and 15. And as you can see that this x game works perfectly. Okay? So I'm going to put this in the center. So I'm going to have 10y squared plus 2y minus 15y minus 3. Okay, I didn't change the problem. All I did was replace the middle term with these two numbers that can be combined to give you this and have a common factor with these two numbers, 10 and 3, which is 30. Okay? All right, now I'm going to break it down the center and factor by grouping. All right, so to make it easy, let's decompose it completely, each term, so I can see what I can factor out, the greatest common factor. So this is 2 times 5 times y plus 2 times y minus 3 times 5 times y minus 3. When you're doing this procedure, you have to break it in front of the sign, okay? All right, now what can I factor from the first pair to the left side of my partition? I can take out 2 and 2 are common, and I can also extract a y. Okay, so when I take out 2y, I'm left with 5y, 5y plus 1. Okay, all right, and then over here, I'm going to take out 3 and a 3. And also, whatever sign you have in the middle, you always bring it down. So since I'm taking out a minus and a 3, I'm going to be left with 5y. Now, what happens when you divide a minus by a minus? you get a plus because minus times plus is minus, okay? Anytime you divide two signs that are the same, you always get a plus, okay? So plus over plus is plus, and minus divided by minus is plus also, all right? Okay, so negative 3 divided by negative 3 is 1. If you want to check your work, you just distribute, you end up with that, all right? So this is good because the two quantities I have in the parentheses are identical, so that's exactly what I want. So what I'm going to do now is I'm going to take this 5y minus 1. These two identical terms are common factors on both sides of my partition, so I'm going to factor them out. 5y plus 1. And what am I left with? I'm left with 2y minus 3. Okay? So 2y minus 3. All right, so our answer is 5y minus 1 and 2y minus 3. Correct answer is B. Notice how all the distractors are very, very similar. So the slightest error with signs, you're going to fall into a trap. Okay, so you got to be really careful when factoring. All right, there you have it. Okay, number 12. It says, for what real numbers is x squared minus 6x plus 9 negative? So if a number is negative, then it's less than 0, right? Because on the number line, anything to the left of the number line represents a set of negative numbers. So what we're solving is the equation x squared minus 6x plus 9 as less than 0. Okay? When solving quadratic inequalities, we have to set up regions, and then we have to use test points to see which satisfy this original inequality. All right? So to set up our partitions where the sign change happens, I have to factor this first. So let's go ahead and factor that. What I'm doing is, well, let me show you what I'm doing here. I got to solve, first of all, solve this equation right here. If I solve this equation, it tells me the partition where I can break up my regions for testing. Okay, so let's solve this first. Okay, so we all know how to solve quadratic equations. We can either use the x game, or we can use completing the square, or we can use the quadratic formula. Let's use the x game here. Hopefully this is a factorable. So I'm going to use the AC method again. AC goes on top, B goes on the bottom. AC is 9, because there's a 1 here. 1 times 9 is 9, and B is negative 6. Okay? So two numbers are multiplied to give you 9 and add to give you 6, negative 3 and negative 3. That's not hard to come up with. So I'm going to have x squared minus 3x minus 3x plus 9. If I factor down the center and factor by grouping, I'm going to have x times x minus 3 minus 3 times x minus 3. So basically we have x minus 3 times x minus 3. Okay? So basically we have x minus 3. If it repeats itself, its square equals 0. So let's solve this. To solve this, I'm going to take the square root of both sides to get rid of this square here. And that gives me x minus 3 equals 0. And I add 3 to both sides, and I have x equals 3. So guess what? This is my partition. This is where the sign change happens, if any. Okay, you can never assume that a sign change happens, but if it does happen, it's going to be about this partition right here. Okay? Because sign change happens when you go from negative to positive. Or when you go from negative to positive, if you think about it, what are you jumping over? You're jumping over 0, right? Because 0 separates the negative world from the positive world, right? Okay, so what we're going to do is we're going to create a partition, and then we're going to start to test. We have only one boundary point here, so we're going to have two regions or intervals to test, okay? In certain cases, you might have more than one, so you're going to have a lot of work to do, but this one is a good one. So let's create our number line. We just solved x equals 1. X equals 3 as a partition. So this is where the sign change happens, if any. Okay? We're not going to test this point because there's no line here, so the boundary point is excluded from the solution set. Okay? So it's either going to be this region, or this region, or neither. Okay? All right, so let's pick test value. So this is interval number 1. This is interval 2. Pick a number to the left. Let's pick x equals 1, because it's to the left of 3, and to the right, let's pick x equals 4. Okay? So either both of them will work, one of them will work, or none of them will work. All right, so we're going to test it to see. So we're going to test So for interval 1, we're going to test x equals 1. What on earth does that mean? This means that if I plug in 1 into the original this equation, this inequality, do I end up with a true or false statement? Alright, so let's do it. So 1 squared minus 6 times 1 plus 9, is it less than 0? That's the question. Alright, let's work it out. 1 minus 6 plus 9 is it less than 0. 1 minus 6 is negative 5 plus 9 is it less than 0. Minus 5 plus 9 is 4. Is 4 less than 0? Absolutely not. This is false. So guess what? Interval 1 is bad. Okay? So this interval is no good. Alright, so now let's go ahead and test interval 2, which is x is greater than 3. So we're going to test x equals 4, because that's a number that satisfies this interval, that's in this interval right here. Alright, so on this region. Alright, so let's put it in. What we're going to do is put it into this inequality right here, and see if we end up with a true statement, okay? So the question is 4 squared minus 6 times 4 plus 9, is it less than 0? Is it? 4 squared is 16, 6 times 4 is 24, plus 9, is it less than 0? Let me add it. 16 plus 9 is 25, right? Yeah, so 25 minus 24 is it less than 0? 25 minus 24 is 1. Is 1 less than 0? Absolutely not. Interval 2 is bad. Yeah, okay? So since both intervals are bad, guess what? There isn't any value of x that satisfies this inequality. So our conclusion is there are no real solutions. Okay, so there you have it. Alright, let's move on to question number 13. It says the root of x squared minus 5x minus 1 equals 0 is. I'm not even going to bother trying to factor because I can see that there are radicals here, so it tells me that it's prime. So I'm just going to go straight to what works, which is the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, you can also use completing the square here, but that's too complicated. Let's use this. Mistake most people make here is that they make errors with your signs. So please, please, please be careful with your negatives. This one and that one. Those are big pitfalls that people make, okay? All right, so we have x squared minus 5x minus 1 equals 0. Before you apply the quadratic formula, you must write this in standard form. Powers have to be in descending order, and it has to be equal to 0, okay? So that's the case here. We have the first term is degree 2, 1, and 0. Excellent, and it's equal to 0. So we're good to go. So what is a? There isn't any number here, so we're going to use the multiplicative identity, which is 1. Anytime we don't have a coefficient, a visible coefficient, you always use 1. So a is 1. B is negative 5. And C is negative 1. Remember what I said earlier. Please, please, please be careful with your signs. Don't lose your signs, okay? Or else you fall into a trap. All right, let's go ahead and work this out. We're going to have x equals negative minus 5 plus or minus the square root of b squared, which is negative 5 squared, minus 4 times a times c. Now, another strategy to help you work carefully when you're dealing with your signs is using parentheses when substituting, okay? That forces you to consider the signs, all right? Times 2a, 2a is 2 times 1. All right, now, we're just going to use order of operations to simplify this arithmetic expression on the right. Minus 5 times minus 5 is positive 5, plus or minus the square root. Negative 5 squared is 25. 1 times negative 1 is negative 1, times 4 is positive 4, plus 4 over 2 equals 5 plus or minus the square root of 29 over 2. So we have two solutions here. First one is 5 minus root 29 over 2. And then the second one is 5 plus root 29 over 2. Okay? So which one works? Let's see. Option letter E, obviously. That's the only one that matches. So our answer is E. Okay? All right. Let's move on to the next one. Question number 14. It says the xy plane, wait just a minute. Okay, it says in the xy plane, the graph of y equals x squared, and the circle with center 0, 1 and radius 3 have how many points of intersection. So I had to change my background to a grid because I need to graph this, okay? So what I'm going to do is I'm going to go ahead and graph this quadratic. I'm going to graph y equals x squared. And also I'm going to graph the circle with center at 0, 1 and radius of 3. Okay, so when I graph these two, it will be obvious what the solution is. So how do you graph y equals x squared? Well, let me make a little table on the right to help me graph y equals x squared. Basically, all you do is you square your x's, right, to generate your outputs. So I don't need too many values here because just a few inputs will help me see the orientation of the curve and also the range. So x and y equals x squared. So when x is 1, y is going to be 1 squared, which is 1. When x is 2, y is going to be 2 squared, which is 4. I think this should suffice. All right, so let's go ahead and sketch it. Sketch the two curves, and that will tell us what the answer is, okay? All right, so I'm going to start out with my quadratic function, y equals x squared. So I'm going to put that one in blue. So for y equals x squared, we know it starts, let me put in 0 so that um, there isn't any ambiguity as to where to start. So how about 0? What happens at 0? Y is equal to 0 squared, which is 0 also. Okay. All right, so let's graph that. So we're going to have 0, 0, and then 1, 1, 1, 1, and also negative 1. Okay, and then for 2, you can have, for 2 goes to 4, 1, 2, 3, 4, and then it goes the other way. The reason why I'm graphing it this way is we know that y equals x squared is symmetric about the x-axis. So you can just go the same distance. Just use a mirror image to reflect it because we know it's a parabola. If you're not sure how this orientation works, you can always put in more values here. Like you can put in negative 1. And then when you put in negative 1, you see that you're going to end up with the same thing. All right, let me just put it for you to see. So negative 1 is negative 1 squared, which is equal to 1. Negative 2 is negative 2 squared, which is equal to 4. You don't have to do this if you remember that the graph of the parabola is symmetric. So you just need a few points here and just reflect it to the other side to get the rest, okay? So let's go ahead and draw what our parabola looks like. Okay, let's put through there something like this, and it goes up. Hopefully this is sufficient to see how many intersections happen. All right, so cut it through there. This is just a sketch, okay? So pardon my ridiculous graph. So let's take a look at the next one. A circle with center 0, 1. Okay, where 0, 1. 0 on the x, 1 on the y. All right, there goes the center, and radius 3. What on earth does radius 3 mean? It means that a collection of points 3 units away from here define the circumference of the circle. Okay, so we're going to go 3 units in all directions. I'm just going to go four directions so that we have a general idea, okay? I'm going to go north, 1, 2, 3. South, 1, 2, 1, 2, 3. 1, 2, 3. East, 1, 2, 3. And west, 1, 2, 3. Remember, these are just sketches to help us see the general orientation of the curves, and then we can see how many intersections occur, okay? All right, so there goes my circle. Yeah, okay? How many intersections can you see? Only 2 intersections. First intersection right here, second intersection right there. Okay, so the answer to this is option letter C, 2 intersections. All right, okay, moving along to question 15. It says if an equation of linear function is in the figure above is y equals mx plus b, then m is what? Now this is a really, really tricky question where you can easily mess up with the signs. So if we stick to the formula for slope, it's very difficult to make a mistake. So what's the formula for slope? We know slope is rise over run, which is basically y2 minus y1 over x2 minus x1. Okay, if you stick with this coordinate formula, you're not going to mess up slope calculations. It's going to be hard. Okay, so we have 2 points. We have s0 as the first point, and then let's call this P1. And then this the second point is 0R. Okay. So how do we apply this formula here? We just label them, right? X1, Y1, 4.1, and then X2, Y2, 4.2. All right, and then we're going to input these variables into a formula to calculate the slope. All right, so we're going to have M equals Y2 minus Y1 is R minus 0 over X2 minus X1, which is 0 minus S. So we're going to have R minus 0 is R, and then 0 minus S is just negative S. And this is the same thing as negative R over S. All right, so your final answer is option letter A. Okay, so there you have it. Yeah, it's very tricky because you have this line going up in an upward orientation. So you might say, oh yeah, it has a positive slope. So this should be the answer, but that's wrong because you notice this S right here doesn't have a sign to it. So that's like a very tricky question. So you gotta be careful here. Okay? But if you use the formula, then you can't fall into any trap. Just use the formula and you should be fine with the sign determination. Alright? Okay, moving right along. All right, let's take a look at number 16. It says, I'm ordering the letters TUV and W from left to right. One ordering, sorry. One ordering of the letters TUV and W from left to right is UTVW. What is the total number of orderings of these letters from left to right, including UTVW? So I'm going to show you two ways of doing this. One is using an organized list, and the other is using a formula. Okay, so we're ordering four letters. 1, 2, 3, 4. So how many different ways can we order them from left to right? In this case, since we have only four letters, there's not going to be any repetitions, okay? Because when you take one letter, it's gone. All right, so since I have four letters, T, U, V, W, how many letters can go into spot number 1? 4, right? 4. All right, one of them is taken. So how many letters do we have left? 3 letters. How many can go into the spot number 2? 3 letters, right? All right, another one is taken. So let's see, another one is taken. How many letters do we have left? 2. How many can go into spot number 3? 2. And then we have one left for spot number 1. If you multiply these numbers together, it tells you the total number of orderings of these letters from left to right, which is 4 times 3 is 12, times 2 is 24. Okay, so our answer is 24. All right, another way to do this is by using permutation or combination. So, is it perm or comb? This sounds like hairdo problem. Perming your hair and combing your hair. It's quite interesting. Anyway, permutation or combination, this is always a question people always ask. We know the formula for permutation, NPR, is given by n factorial over n minus r factorial. And the formula for combination, NCR, is given by basically the formula for permutation, but we just take away the order by inserting this r factorial down here, okay? So which of these is applicable to this situation? Now, if you think about the synonyms for permutation, that should help answer the question, okay? So permutation, let me write it out completely. Permutation, let me write it again. Permutation has a whole bunch of synonyms that can help us determine what the right selection is. So permutation or a combination. So the question is, which one is applicable to this problem? Permutation, another word for permutation is placement or order. Okay, or place. Okay, or arrangement. So what are we doing here? We're arranging letters, right? Even though you look at the question, it says ordering. So, bam, that automatically tells you that permutation is what we're using, okay? Combination has to do with just choice. You're free to just choose wherever you want to place it in. There's no order here. So permutation involves order, and this one has no order in it, okay? All right, so we're going to be using the permutation formula for this problem, okay? So we already established that our answer is 24, so we better get the same answer or something is terribly wrong, okay? So, we're ordering 4 letters, choosing 4 at a time. How can we order 4 letters choosing 4 at a time? So 4, choose 4, place 4, or 4, order 4. Okay? So n is 4, r is 4. So applying this formula, we're going to have 4 factorial over 4 minus 4 factorial. Okay? Remember, n is 4 and r is 4. Okay? Whenever you're ordering all elements of a set, these two numbers are basically the same. So we're going to have 4 factorial over 0 factorial. 0 factorial is 1 by definition, so 4 factorial over 1 uh, over 1. Let's see, my computer is freezing here. Okay, 4 factorial over 1. All right, and then 4 factorial, we know the rules for factorial, right? You just multiply all the way down, counting down to 1. So it's 4 times 3 times 2 times 1 over 1. So 4 times 3 is 12. 12 times 2 is 24. Voila, there we got it. Okay, so you can use the formula or you can use this ordered list process. You'll get the same answer. All right, let's move on to question number 17. It says if uh, f is given by this, and f to the negative 1 is the inverse of f, what is the value of f to the negative 1 of f? Okay, f to the negative 1 of 3. So we need to find the inverse of this function first, and then we're going to input 3 into the inverse and see what we get. Okay? All right, so let's do it. We're going to have, instead of writing f of x, remember y is the same thing as f of x, right? So for symbolic convenience, instead of writing f of x, I'm going to write y equals 3x minus 1. So when you're taking the inverse, your output becomes your input, and your input becomes your output. So what I'm going to do is I'm going to switch. I'm going to switch my y and my x's. Okay, because I want my in to be my out. Remember, x is your independent or input, right? And y is your dependent or output, right? So I'm going to switch them. So switch your x and y's. I'm going to have, I'm going to put it in blue, so change the color so you can see it. X equals 3y minus 1 over 2. What did I just do here? I just switched the x and the y's, okay? Because that's what inversion is all about. Now, if I solve for, after switching, I need to solve for y, and that will be my inverse. Okay, that's going to be my inverse. So let's solve for y. To solve for y here, I'm going to multiply by 2, so add 1, and divide by 3, and that'll get y by itself, all right? All right, let's do it. So multiply by 2 first. So we're going to have 2x equals, this divide out, 3y minus 1. And then I'm going to add 1 to both sides. I'm going to add 1. Using the reflexive property of equality, I want my y on the right side, so let me just switch it around. I mean on the left side, so I'm going to have 3y, because these add out to 0, equals 2x plus 1. Okay? And then divide both sides by 3. That should complete my solving process for y. Divide by 3, divide by 3. This divide out to 1. And I'm going to have y equals 2x plus 1 over 3. All right, what on earth have I just created? I have just created the inverse of the function, of this original function. So guess what? F to the negative 1 of x equals 2x plus 1. Okay, are we done? 2x plus 1 over 3. Are we done? Absolutely not. We're asked to evaluate the inverse at x equals 3. So what does that mean? It means that anybody have x, you're going to plug in 3. Okay? All right, so let's do it. So we have f to the negative 1 of 3 equals 2 times 3 plus 1 over 3. Okay? All right, so 2 times, using order of operations, you multiply first. 2 times 3 is 6, plus 1 is 7. 7 over 3 is your inverse of f at 3. Okay, so the answer is option letter E. All right. Now let's move along to question 18. We have a sequence right here given by this recursive definition for n starting from 0 all the way up. What is the value of a sub 3? Okay, so we're going to work step by step. We know that a sub 0 is 1. Okay, the next one, a sub 1, is recursively defined in terms of a sub 0 is going to be, what is a sub 1? It's going to be 2 a sub 0 plus uh, plus 2. Okay? I hope this makes sense, what I just did. In this case, we're setting n to 0. Okay? Let me just show you the steps on the side here. So we have, this is the recursive definition. A sub n plus 1 equals 2a sub n plus 2. Okay, so I'm claiming that a sub 1 is this. So let's see if that's true. Remember, it starts from n equals 0. So I'm going to have a sub 0 plus 1. Okay, note n equals 0. Equals 2 times a, since n is 0, a sub 0 plus 2. If you work this out, you have a1 equals 2a0 plus 2. Okay, so that's how I came up with the first definition here. I set n to 0 because that's the first one. Okay, all right, let's evaluate what that's going to be. So a1 is going to be 2 times a sub 0 is 1, so 2 times 1 plus 2, which equals 4. Okay, all right, now we need to move to the next step. The next step is n equals 1. So to find that, we're going to have, that's going to give us a sub 2, 1 plus 1, which is basically a sub 2, is going to be 2, a sub 1, a sub 1 is 4, right? The one that's before it, 2 a sub 1 plus 2. Okay, you always use the one that's before it. Okay, just as I use the one that's before this in here. So 2 a sub 1 plus 2 is going to give us, 2 times 4 is 8. 8 plus 2 is 10. Okay? All right, and then for n equals 3, which is the final one we need, that's going to give us a sub 1 is, oh, not n equals 3, huh? It's n equals 2 that we're working with here. So for n equals 2, it's going to be a sub 2 plus 1, which is a3, which is what we're looking for. So a3 is going to be 2a2. Let me just put it here so you don't get confused. 2a2 plus 2. Okay? All right, so what does that mean? 2 times the one you got before, a2 is 10, right? So put it here, 10 plus 2. Okay? And then when you work it out, this is going to become 2 times 10, which is 20, plus 2, which is 22. Okay? So there goes your final answer. E is 22. All right, so just remember, this recursive definition involves plugging in the previous output. See this one right here? I plugged it in to this one, okay, to get a1. And then for a2, you see this one right here? I took a1 and I plugged it into a2. And then to get a3, I took a2 and I plugged it into the recursive definition. Okay, you keep plugging in the previous one. That's the connection here. You keep plugging in the previous one into the original one to get your output. All right, so hopefully I didn't confuse you with my arithmetic here, but that's what I'm just simply doing. Keep plugging in. So I plug in a0 here, plug in a1 here, and I plug in a2 there. Okay, so that's how it works. All right, question number 19. It says 5 employees at a company. A group of 3 employees will be selected from the 5 will be chosen to work on a project. How many different groups of 3 employees can be chosen? So the question here is this combination or permutation? Okay, let's write out the formulas again. NPR, we talked about this earlier, is basically n factorial over n minus r factorial. And then NCR is n factorial over n minus r factorial r factorial. Okay, so which one are we going to use? Remember I told you permutation has to do with order or placing or arrangement. Okay, so out of these 3 people that have been selected, are they going to be ordered in any particular way, fashion? No, there isn't any order in here. Remember I told you later that combination meant choice. You can choose anybody in any choose or choice. Okay, There's any placement here, so you can see it says the chosen. So they're chosen and they're not placed in any specific order, so this is going to be a combination problem because there's no order involved here. Okay, so guess what? We're going to be using this formula. All right. So n is the complete set of people, which is 5, and r is how many you're choosing, which is 3. Okay, so out of 5, choose how many ways can you choose 3? Okay, so we're going to be using the combination formula. 5c3 is going to be 5 factorial over 5 minus 3 factorial, 3 factorial. So all I basically did here was plug in 3 for r and n for 5. Okay, so let's work it out. So we're going to have 5 factorial over 5 minus 3 factorial is 2 factorial, 3 factorial. Okay, I'm going to break down the 5 factorial down to the bigger of the 2 in the bottom to save me time. But if you have energy, you can break everything down and work it out from there. But I'm going to be work smart here. So I'm going to go 5 times 4 times 3 factorial stop. As the bigger of the 2, I'm going to get rid of the bigger problem as opposed to the smaller one. I'm going to break this and keep this, okay? So 2 factorial is 2 times 1. And then let's leave 3 factorial alone. Why? Because it matches with what's on the top there. So these two divide out. 5 times 4 is 20. We have 20 over 2, which is 10. Okay? So the correct answer is 10 ways. You can choose 3 out of 5 in 10 ways. Okay? Okay, last but not least, number 20. It says if f of x is 1/3 3x and a is less than b, which of the following must be true? So working with problems like this is always good to have concrete numbers to work with. But if you know that this is like a decay function, if I knew what the graph of this looks like, I can absolutely tell you the answer without doing any work. Okay, because I know this is a decay function. It's something like this. Okay, so I know based on how this looks like that the values keep getting smaller and smaller, and if a is less than b, I guarantee you that f of a is going to be greater than f of b because f of b is smaller than f of a. Okay, because it's getting smaller. When something decays, it keeps getting smaller. All right, that's because the absolute value of a is less than 1. Okay, if it were bigger than 1, then it would be a growth. So this is abstract. Let's work with something concrete, okay? So to make us confident as to what our answers are, we're going to pick numbers, okay? So how about we say a equals 1 and b equals 2? We're going to plug in these test values into this function and see how they compare, okay? So f of a is going to be what I get when I plug in. So it's going to be f of 1. So I'm going to plug in 1 into my function. My function f of x is 1 over 3 dx. So it's going to be 1/3 raised to the first power, which is just 1/3. Okay? All right. F of b is f of 2, which is 1/3 squared. What is 1/3 squared? You know what you're going to do? You're going to square the top and the bottom. So it's 1 squared over 3 squared, which is 1 over 9. Okay? So how do these two compare? If I add these two together, do I get 3? Absolutely not. But let's look at the size though. To compare them, how about I make them have the same denominator? I make them the LCD. I make their denominators common. So to make this one have the same denominator as that, I need to times both top and bottom by 3. So this becomes 3 over 9. Okay? So how do they compare? You can clearly see that f of a is greater than f of b. Okay? So be careful with your inequality symbols here. Remember, the alligator always eats the bigger meal, right? This is the alligator right here, and put the eyes on it. So this is a bigger meal, so that's what it's going to eat, right? So f of a is bigger than f of b because if you look at it, like I said earlier, this is a decay function, it's a decay model. So the outputs keep getting smaller and smaller, and at infinity, they get really, really close to 0. So the answer is clearly option letter E. Okay, f of a is bigger than f of b. So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel so you can get updates to other cool videos such as this. Please help support the creation of videos like this by commenting or liking this video. I really appreciate it. More videos can be found on Mathgotserved.com. Thanks again and have a wonderful day.